Hello and welcome back. This time we've got a probability question. Let's read it together. A dice has 2 green faces, 2 blue faces, and 2 red faces. It is rolled 8 times and the face on top is recorded. How many elements are there in the sample space? So just remember, elements, that refers to a result, and sample space is the collection of all the results. So if we break this question down a bit, it says it's rolled 8 times. If we think about this and it was just rolled once, how many elements could there be in the sample space? It would just be 3. We would either have green, blue, or red. If it was rolled twice, we would have 9 results, because we would just multiply the number of outcomes together. Now here, if we had this dice rolled 3 times, we would multiply by another 3. So you can see where we're going with this. And eventually we will get 3 to the power of 8. And we just have to work out what 3 to the power of 8 is, and that'll be the number of elements in our sample space. So have a go at working that one out on your own. What did you get? Did you get 6,561 elements? Because if you did, that's fantastic. That's what I got too. Now let's look at question B. What is the probability that 8 green faces in a row will occur? Well, again, let's break this down. Instead of thinking about it as 8 in a row, let's think about it just once. What's the probability that we will get 1 green face? That'll just be 1 out of 3. Let's extend this to 2 green faces in a row. We will just multiply that probability by 1/3 again. And if it was 3 green faces in a row, we would multiply that by 1/3 again, and so on and so forth, until we get to 1/3 to the power of 8. So we just have to work this out. We can just put that in the calculator and we will get 1/6,561. And that would be the probability of getting 8 green faces in a row. Fairly small probability. Question C says, why is part B one of the easiest questions that could be asked about this event? Well, we're just multiplying 1/3 over and over again. That's about it. We don't have to think about what if the colors change, what's the probability that it's not 8 green faces, what if we get 5 green faces, and they don't have to be in a row. There's a lot of variables that could make this question a lot harder, but luckily it is definitely one of the easiest. For part D, what are the other equivalent questions with the same answer? Well, we have to think about what kind of question would have the same probabilities. So instead of having 8 green faces, what if we had 8 red faces? So what's the probability of getting a red face? That's 1 out of 3 as well. And what about 8 blue faces in a row? Because the number of blue faces is 2 out of 6, which is the same as 1/3. So the probability for 8 red faces and 8 blue faces would be the same for that. Now for question E. Consider the question, what is the probability that none of the faces will be green? This seems like an application of complementary probabilities to the event in B, but it is not quite that easy. Why not? So this one, we might need a bit more space for that. A complementary event just means that the probability of A plus the probability of not A, that's what that little apostrophe means with the A, that should equal 1. So if we did treat question B like a complementary probability, the chance of none of the faces will be green, that would just be probability of 8 not green. Would that equal 6,560 over 6,561? Well, let's break this question down a bit more. Instead of saying none of the faces will be green, what about the probability that it's not green to begin with? So just one roll of the dice, probability that it's not green, that would just be 2 out of 3. And if we wanted to do the probability of 8 not greens in a row, that would just be 2 over 3 to the power of 8. And what does that equal to? Well, we know what 3 to the power of 8 is. We know that's 6,561. What is 2 to the power of 8? I'll let you guys work that out on your calculator quickly. Now, if you got 128, you're a little bit off the mark. That was 2 to the power of 7. 2 to the power of 8, though, is 256. Now you can see there's a big difference between what we first thought, if we thought of it as a complementary event, and what we actually get. And the reason is because there's so many chances in those 8 rolls that one of those faces could be green. The chance that none of them are green is probably not that big. So that's why we've only got 256 over 6,561. And that's it for today. Thanks for joining me, and I'll see you next time.